Throughout history, humans have looked up at the sky and wondered about our place in the universe. One fundamental question has captivated thinkers for centuries. What is the shape of our world? Is it flat, like an endless plane? Or is it a sphere, floating in the vastness of space? The answer, as we shall see, is not a matter of belief, but of scientific evidence. The idea of a flat Earth persisted for a long time. Ancient civilizations often envisioned the Earth as a flat disk, surrounded by a dome-like sky. But as our understanding of the natural world grew, so too did our knowledge of Earth's true form. Today we have overwhelming evidence that confirms beyond any doubt. Earth is a sphere. This essay will explore the key scientific observations that have shattered the myth of a flat Earth and revealed the true nature of our planetary home. It's easy to understand why early civilizations believed in a flat Earth. Their world was limited by the horizon, and the sky appeared to arch overhead like a dome. Ancient cultures developed elaborate myths and stories to explain the movements of the sun, moon, and stars across this seemingly flat expanse. However, even in ancient times, some keen observers began to notice clues that suggested a different reality. The ancient Greeks, in particular, made significant strides in understanding Earth's spherical nature. Philosophers like Pythagoras and Aristotle, as early as the 6th century BC, proposed a spherical Earth based on observations of lunar eclipses and the changing positions of stars. One compelling piece of evidence they cited was the way ships disappeared hull first over the horizon. This phenomenon, they reasoned, could only be explained if the Earth's surface was curved. Their insights laid the foundation for a more accurate understanding of our planet's shape. One of the simplest yet most compelling pieces of evidence for Earth's curvature lies in a familiar sight: ships sailing over the horizon. As a ship sails away from the shore, it doesn't simply shrink in size until it vanishes. Instead, it gradually disappears hull first, with the mast visible long after the lower part of the ship has dipped below the horizon. This phenomenon wouldn't occur on a flat Earth. If Earth were flat, a ship sailing away would simply get smaller and smaller until it was too tiny to see, but it would remain entirely visible. The fact that ships disappear hull first is a clear indication that the Earth's surface is curved. Furthermore, if you were to watch a ship approach the shore from a great distance, you would first see the top of the mast appear above the horizon. As the ship drew closer, more of its hull would gradually come into view. This too is consistent with a curved Earth and impossible on a flat one. Another compelling piece of evidence for Earth's spherical shape comes from the realm of astronomy. As we observe the night sky, we notice that different constellations are visible from different parts of the world. For instance, the Southern Cross constellation is visible from the southern hemisphere, but not from most of the northern hemisphere. Conversely, the North Star, Polaris, is visible from the northern hemisphere, but not from the southern hemisphere. This phenomenon wouldn't occur if Earth were flat. On a flat Earth, everyone would see the same constellations, regardless of their location. The fact that different constellations are visible from different latitudes is only possible if Earth is a sphere. Imagine Earth as a giant ball, with different observers standing at different points on its surface. Their view of the night sky would be determined by their location on the sphere, with those in the northern hemisphere seeing a different portion of the sky than those in the southern hemisphere. Section 5. Eclipses. Shadows in space. Eclipses, both lunar and solar, provide further compelling evidence for Earth's spherical shape. A lunar eclipse occurs when the Earth passes between the Sun and the Moon, casting its shadow onto the lunar surface. During a lunar eclipse, observers on Earth see a curved shadow gradually move across the face of the Moon. This curved shadow is, in fact, the shadow of Earth itself. The only shape that can consistently cast a round shadow, regardless of its orientation, is a sphere. If Earth were flat, its shadow during a lunar eclipse would be elongated or elliptical, depending on the angle of the Sun. The ancient Greeks, as mentioned earlier, recognized the significance of this observation. They reasoned that the consistently round shadow cast by Earth during lunar eclipses provided strong evidence for a spherical Earth. Section 6. Day and Night. Evidence of a rotating sphere. Our daily experience of day and night also provides compelling evidence for Earth's spherical shape and its rotation on its axis. As Earth spins on its axis, different parts of the planet face the sun, experiencing daylight, while the opposite side faces away from the sun, experiencing night. If Earth were flat, it's difficult to explain how day and night could occur as we observe them. Some flat Earth proponents have suggested that the sun is a small nearby object that circles above the flat Earth, illuminating different regions as it moves. However, this model fails to explain many observed phenomena, such as the varying lengths of day and night throughout the year or the existence of time zones. The concept of time zones, in particular, is a direct consequence of Earth's spherical shape and rotation. Because Earth is a sphere, different locations on its surface experience sunrise and sunset at different times. Time zones were established to account for these differences and to synchronize timekeeping across the globe. Section 7. Shadows and shape. More clues from the sun. The sun's rays provide yet another line of evidence for Earth's curvature. If Earth were flat, the length of shadows cast by objects at different locations on Earth would be the same at any given time. However, this is not what we observe. In reality, the length of shadows varies depending on the angle at which the sun's rays strike the Earth's surface. At the equator, for example, the sun's rays strike the Earth at a near perpendicular angle, resulting in short shadows around noon. As you move towards the poles, the angle of the sun's rays becomes more oblique, resulting in longer shadows. This variation in shadow length is a direct consequence of Earth's curvature. If Earth were flat, the sun's rays would strike all parts of its surface at the same angle, resulting in uniform shadow lengths. The fact that shadow lengths vary with latitude is another piece of evidence that supports a spherical Earth. Section 8. From above, the view from space. Perhaps the most definitive evidence for Earth's spherical shape comes from the countless images and videos captured from space. Since the dawn of the space age, we have launched numerous satellites, probes, and even humans into orbit around Earth. These missions have provided breathtaking views of our planet from afar, leaving no doubt about its spherical form. Astronauts aboard the International Space Station, for example, orbit Earth every 90 minutes, witnessing multiple sunrises and sunsets each day. Their vantage point affords them a unique perspective on Earth's curvature, as they can clearly see the planet's curved horizon against the blackness of space. Moreover, the images and videos captured by satellites and probes show Earth from various angles and distances, all consistently depicting a spherical object. These images, readily available to the public, provide undeniable visual confirmation of Earth's true form. Section 9. Conclusion: embracing scientific understanding. The evidence for Earth's spherical shape is overwhelming and comes from multiple lines of scientific inquiry, from the simple observation of ships disappearing hull first over the horizon to the complex calculations of astronomers studying celestial objects. All signs point to a spherical Earth. While it's understandable that ancient civilizations, limited by their technology and understanding, may have believed in a flat Earth, today we have no excuse for clinging to such outdated notions. The scientific method, based on observation, experimentation, and logical reasoning, has provided us with a clear and accurate understanding of our planet's shape. Embracing scientific understanding is not just about accepting facts. It's about cultivating a sense of wonder and curiosity about the world around us. It's about recognizing the power of human ingenuity and our ability to unravel the mysteries of the universe through careful observation and critical thinking. So the next time you gaze up at the night sky or watch a ship sail over the horizon, remember that you're witnessing evidence of Earth's remarkable spherical shape, a testament to the power of scientific inquiry.